have 1 hour for really tough content. We are going to study the application security and bug hunting. And we will start from the fundamentals. But if you are a security expert, if you are application security engineer, you can create a roadmap based on this presentation, based on this content. You can create your own roadmap, how you can develop yourself as a bug hunter. Before we start, a few words about me. Formerly, I was a head of application security and product strategy in an American company. That's why we're discussing the application security issues. And most important, I was the Kaspersky grade security researcher who was focused on security assessment and vulnerability research of emerging technology. And that's why probably I'm here, and that's why I want to say thank you, my great friends, for this invitation. And this is a quick roadmap of our workshop. First of all, it will be a quick introduction about why we need to dig deeper, for what we are choose the topic related to application security, not a binary issues, not a reverse engineering, but application layer. What is attack surface and how application layer related to attack surface, and how to assess the attack surface using the reconnaissance. What kinds of reconnaissance techniques we can use to discover something interesting. And of course, it's application security and bug hunting. We will try to dig deeper and understand some kind of bugs, security bugs. But it's entry level, so don't expect any kind of advanced security, but I'm sure you will extract something interesting. And in the final stage, I think and I hope I see you in official stage in Barcelona. Let's go. First of all, why application security? I know that here is the mostly engineers and guys, security researchers who focus it only on binaries, on malware, on I don't know what you are doing already, but I see only few titles related to security engineering. But here is mostly guys related on low level, respectful guys who can read the assembly, who can read the EDA listing, etc. But from my opinion, application security is more interesting stuff, because here the statistics that demonstrate that application layer is the layer main entry point for any kind of attackers. And if you ask any kind of penetration testers how he breaks the perimeter, you will see that the answer will be social engineering or application security issues. AppSec, exactly. That's why this slide is demonstration and the proof that application layer becomes bigger and important. Application is everywhere. Even this amazing application that we are trying to organize some interaction between audience and the speakers, it's still application. Even our communication right now, our messengers, it's still applications or application layer service. That's why I think applications, that's quite important. It's everywhere. And before we start to break some kinds of apps, we need to remember the main word during our presentation and during our work. It's responsibilities. What I mean about the responsibility, let me check my screen and let me share with you the video that related to responsibility demonstration. Seems that my browser requires extension because I opened this presentation in another browser. Okay, this is another issue related to application layer. But I think I will have some opportunity to switch my browser after the content of the presentation and show you some Kali Linux dashboard. Okay, responsibility. We use some offensive techniques, but we use these offensive techniques to discover something undocumented before attacker discover it. That's why our main word is a responsibility that demonstrate that we need to submit this vulnerability and notify the owner of vulnerable app as soon as possible before the attackers do. So that's a main term, responsibility. And let's start from the term that I mentioned before. It's attack surface. Applications dramatically increase the attack surface. If you ask any security engineers how his workflow looks like, what is a DevSecOps, or what is agile security, or what is a software development lifecycle, you will see that from the security researcher and application security researcher point of view, the product development lifecycle looks like the lot of tools. The tools, the frameworks, I don't know, the infrastructures, the clouds, etc., etc. All this stuff dramatically increase the attack surface. And before we jump in terms of what is the attack surface and how to assess the attack surface using the reconnaissance, let's define the formal view of the attack surface. This is a high and academical slide that demonstrates the typical network. From the researcher point of view, let's describe the attack surface based on this scheme. You see here 3 hosts. One of them, host number 0, divided by firewall. So what is attack surface from the point of view of this scheme? If this scheme has no any kind of firewall, you will see that attacker requires few steps to achieve his root access on host number 1 and host number 2. And here you will see that it's number of steps that attackers should perform to achieve the crown ogival. But if you switched on your firewall, you see that number of steps will be increased, because if you're an attacker, you can use vulnerabilities in the firewall, but it's still possible. So that's why, from the scientific point of view, the attack surface is a number of steps and the number of paths that you need to perform to achieve your crown of jewels. And if we go back to the terms of attack surface from the practical world, you will see that number of interaction points related to your target dramatically increases, because your target has the application layer. Application layer has a lot of applications and has a lot of frameworks for development in other applications. Sometimes application generates another application. So that's why the surface increases on application layer. And if you're trying to scan any kind of enterprise level network, external perimeter or internal perimeter, you will see that there are a lot of interesting assets. It's mostly related to application layer. It's web portals, it's stuff for the management panels, it's kind of devices or IoT devices that have applications, etc., etc. So it's a typical graph that you can extract from the scanning tools, and you will see that your network of your enterprise level target has a lot of applications. That's why for you is a main entry point. And we are, as a security researcher who focused on AppSec as a bug hunters, we need to have the skills to assess the targets, to collect the attack surface. And before we start to exploit something, we need to organize the assessment of the attack surface. We need to use the reconnaissance techniques. And first of all, of course, few examples from the real life. If you will extract external perimeter, you will see another interesting fact, that we are like a security engineers, we also increase the attack surface. Of course, we are here to save the world, but in our workflow requires some additional tools for security purposes. But these tools, if these tools exposure it to the internet, you can use, if you're an attacker, you can use these tools to compromise the perimeter too. So this is a SonarQube example. This is a code quality tool. And if you know what is that, it's just framework that allows you to input your source code of your product, to include the pipeline of this product to the pipeline of your product development lifecycle, and you can assess the code quality and security. So you can proceed the basic security assessment for your intellectual property. But sometimes you can find exposure at SonarQubes available for everyone. And if you will use the Shodan, who someone already mentioned the Shodan as a search engine, you can see that how many security engineers or unqualified developers exposure the SonarQube for everyone. And where's the impact? the impact that anyone can compromise the Sonar Cube if the Sonar Cube has some exploits, public available exploits, or it allows you to register there, and you can extract the intellectual property, the code, source code of scanned product. Sometimes Recon can help you to extract something sensitive that's available, but still can't be exploitable for like an entry point. This is an example of secrets that was exposed to everyone on the GitHub. If you use the GitHub scrapping technique, you can insert some interesting words like SonarCube and pass, and you will see some scripts that used SonarCube API to organize the automation for development lifecycle procedures. But the guys who involved in a software development lifecycle sometimes organize the backups of their code related to work. They organize the private repository or a public repository on a GitHub, GitLab, Bitbucket, etc. You are, as a researcher, you can assess the GitHub available secrets using the techniques that we called GitHub scrapping. Also, regarding the SonarCube and the same tools, and the same frameworks, they have the API. And sometimes you can use the special words, keywords of the API that allows you to fingerprint the SonarCube from the thousands, billions, and millions, the same frameworks from the internet. For example, you can extract from the official guide of the SonarCube, you can extract the keyword related to API for logging, and you can extract all scripts related to the logging in different SonarCubes dashboard. So you can use these SonarCubes to compromise the intellectual property. Another one example. This is a product of, this is a commercial product, one of top 3 commercials, and it is an amazing product. That's nothing related to developers of the checkmarks, but the clients of checkmarks that not aware how to use it correctly, because if you, for example, trying to search some checkmarks installations available online, you will see there's some demo test environment. And sometimes you can register there and you can extract the source code that was scanned there, even if registration, only in case registration is available for you. But if you exposure your checkmarks for everyone, for what you switched on your registration point. Also, checkmarks has an API. And as I said before, you can use this API as a GitHub scrapping object. You can try to check sensitive keywords that allows you to connect to checkmarks API. And you can see here that someone tapped his source code related to checkmarks connection, and you can extract the passwords and IP addresses of checkmarks installation that you can compromise. How we can use it? Okay, I will describe you some utilities. First of all, we can use the subdomain search. We can use the utility that we call MS. This is an example of utility that available in Kali Linux in pre-default installation. We can use the keys in MS. No, don't worry, guys. I will share it with the chat. You can open your Kali Linux installation and try to scan this icon. The MS allows you to grab different subdomains that are available in third-party resources. Why I prefer the passive keyword. The passive, it means that you don't touch your target directly. You just collect all subdomains that was saved in archive or in the logs of different services like bug bounty services or who is services, etc., etc. So any kind of third-party databases like Shodan, Census, ZoomEye that allows you to extract all subdomains. And this, in the same time, you don't need to touch your target. That's quite useful for some kind of red teaming. And if you launch this command, this MS, you can extract all subdomains that could directly lead you to different kinds of applications. Also, I mentioned the technique GitHub scrapping. For GitHub scrapping, it's quite useful to use the framework for reconnaissance. My colleagues from field of malware analysis, they mentioned Maltego, but Maltego is maybe interesting mostly to lead and organize your investigation, but not probably so good for application security reconnaissance as much as a Recon-NG. Recon-NG framework. So you see my messages, and I mentioned the reconnaissance tools that allows you to track something interesting about domain names too. And for example, we already extract all subdomains and different kind level of subdomains from the sascon.com. You just put it in the one list. The second list is try to extract something interesting from the GitHub about your target. And if you know the repository of your target, you can use the Recon-NG as a basic framework, like a Metasploit framework that allows you to collect something interesting from the GitHub. And GitHub scrapping is a technique that allows you to extract secrets from the public available repositories. What I mean secrets? Could you please mention different kind of secrets in the chat? Secrets in the source code. First of all, it's a passwords, hard-coded passwords, but I think in 2020 is not interesting to find passwords in the repository. I need more idea what you can find using the GitHub scrapping techniques. Yes, passwords, that's trivial. It's trivial. Credential is trivial, but API keys for AWS or for third-party clouds. Hashes, yes. Some deployment strings that allows you to deploy service and allows you to break the service after deployment. Config databases, emails. Yes, emails will be useful for phishing assessment. So, and for this subdomains too, of course. And MS, as I mentioned before, they already use GitHub scrapping for extraction the domain names. But Recon-NG that I mentioned before, the Recon-NG is a framework that allows you to organize the targetedly GitHub scrapping using different kinds of modules. And one of the modules in the Recon-NG called GitHub Miner. If you will use this framework, sorry, this is a mistake in the GitHub word, you will extract something interesting from the repositories. And if you check, for example, Kaspersky Lab repository, you can extract a lot of sensitive information and interesting, not a sensitive probably, but interesting information for you. You can extract all committers in these repositories. Then you can check repositories of committers. You can extract the numbers of repositories, secrets available in these repositories, etc., etc. And sometimes you can find persons who commit in the target repository, but this person at the same time has own repository with own secret. So this is a type of connections that you can't connect between, and it could be useful for assess the attack surface. So, okay, the first stage was assessment of attack surface, but somehow we need to exploit it. Yes, we need to find the vulnerabilities. And how we will find vulnerabilities? Sometimes you can find something sensitive during the reconnaissance. And according to my experience of penetration test, I think 70% of success defines by reconnaissance stage, not exploitation stage. That's why recon is important. And recon can bring some results, interesting results for you. But you collect the attack surface, you collect the domain names, list of domain names, and you collect probably guys who commit in repositories, you collect the repositories, etc. So a lot of interesting stuff that you need to assess. Let's go next. We need to understand what we are dealing with. And I'm sure, guys, that despite the fact we are fundamentals guys, we're researchers, we understand the fundamentals, we also need to understand what happens if we input the URL or URI in our browser string. What happens, what connections starts when you input the sas.com in your browser. And here there's a short scheme what happens from the browser point of view when user trying to access an arbitrary website. The main point that here on the scheme browser exchanged by request the responses. And what is a request? The basic understanding of requests is a fundamental for any application security engineer. Your browser always try to do the request, and you need to understand what happens when you're trying to access arbitrary resource from the third party from your target. So your browser send the request. Structure of request you can see on this slide. And for your interest, you need to understand what kind of fields exist in this request. The same with the response. You need to understand and you need to be able to read the response. What happens and what kind of configuration available in this response? What kind of conclusions you can perform based on the HTTP response? So you need to understand what is a response and what is a request, right? You need to understand any options, any methods in the request. You need to understand what is a get option, what is the difference between get methods and patch method. What kind of situation you can exploit if for example, if your target accept patch method or trace method. What kind of issues could bring this realization? And so you need to understand what your action, what changed on the server side. So, and the main fundamental that we need to extract from this stage of this slide, the stage from this slide, is HTTP stateless protocol. What I mean stateless? By default, your server, your target, and your web application doesn't understand who is the client between requests. You need to submit something additional in your packet, in your HTTP request, just to make sure that server will understand who you are. You need to implement some additional layers of stateful connections. And this is a basic principle that HTTP is stateless, brings the idea of most vulnerabilities that exist and that related to authentication, authorization issues. So just remember the word. HTTP is stateless, and your application need to understand who is performed the request. So let's go to the application exploitation and to application that useful to tools that useful for security researcher who already collects some attack surface. So the one example is the BurpSuit, and it's trivial. BurpSuit is a traditional proxy server that allows you to manipulate your request and read your response. This is just a proxy server. That's it. You can use any kind of proxy servers to understand what happens between your browser and your server. But BurpSuit or Open Web Application Security Project, Application Security Project developed the open source version of proxy that named OWASP-ZAP. And it's different. I think it's discussion like a religion, what you support, open source or commercial solutions. It's up to you. But I think the open source ZAP and BurpSuit is a leaders of proxy services. And the interface of this proxy services, it's pretty same. They have ability to intercept your traffic, to manipulate your traffic, and then you can assess the response. And this is a proxy that implements a lot of parsers that you can set to proceed any interesting patterns of anomaly behavior from your target. That's it. And we will not describe in details what happens in your BurpSuit. So this is a kind of interface. If I will be able to show you something, but I will show you how to assess and how to organize the basic principles of attacks using the BurpSuit. But I think you can download it, you can install it, because BurpSuit has a commercial version, community version, and you can try to intercept something using the BurpSuit. So, but it's tool number one. And this is an example how the intercepted request between your browser and your server looks like. What you need to do with them is just organize the reverse engineering of communication between your browser and your target application. So this is example of settings that you need to install. But another important for the fundamentals, to understand the fundamentals, important technique is just you need to read about attacks, you need to read about vulnerabilities, but you need to organize your practice somehow. And to organize it, Open Web Application Security Project, or OWASP, they implement the open source project for trainings, for application security trainings, for application security engineers that wants to understand the basic principles of attack. It's a OWASP Juice Shop. It's a vulnerable application that looks like Juice Shop, this trivial e-shop, e-commerce application. You can see the architecture that consists of that main blocks of the application. It's pretty modern application, not classic stuff where you can find the stored XSS or any trivial attacks from the books. But it's a modern application that consists of modern parts like AngularJS, Node.js, and Mongo or SQLite. And I totally recommend you to start from the local host, to start from the Docker containers, to practice and to repeat these principles that we will describe in the future. But also, you probably don't need to install your Docker container. You just open the link at a platform Heroku app, and you can start your practice. But don't do it now, because I see here almost 1,000 people. If you start the penetration testing of this application, you will be blocked, because Heroku blocks for denial of service if you're trying to connect multiple times. That's why just remember this link, and remember that it's possible for you to start your practice without any real target. So let's start from the vulnerability exploitation. So, but before we start with this slide related to cross-site scripting, I think you need to understand why we choose this vulnerability. As a security researcher, you need to start from something, right? You need to choose what kind of vulnerability you will research first. But if you have any basic understanding what's the start point to research, what kind of vulnerability you need to read about, you need to practice, you can open the reports on bug bounty platforms, and you can assess the threat landscape, what happens in application security right now, what kind of reports are popular and submitted by a lot of researchers worldwide. It means if you will see some trends there, you can start your career as a security researcher. You can start from the most popular vulnerabilities, because it means that you have a huge attack surface. And if you choose the most popular vulnerability type to research, to start your investigation, you can collect a lot of interesting stuff from this huge attack surface. But if you start from difficult vulnerability and non-popular vulnerability, probably the results will be not so impressive for you from the beginning point. But it's quite useful if you want to jump in bug bounty programs, and if you understand that whole world of researchers are looking for cross-site scripting. Of course, it's not a good idea to get some money from cross-site scripting. Probably it's a good idea to research new vectors or not popular vectors in different kinds of frameworks, and to dig every element in your attack surface, assess this attack surface for your exclusive vulnerability. Impact will be higher, and so bounty will be higher. That's why there are two approaches. But for beginners, if you're starting from bottom, I think it's mostly interesting to start from the most popular vulnerabilities. So, guys, the question for you: what do you think? What kind of web application vulnerabilities is popular, excluding the cross-site scripting or XSS? Please write in the chat any vulnerabilities that you know and that related directly to application security. Local file inclusion. Okay, so here is a Dino here in the chat. SQL injections, a lot of Dinos. Yes, SQL injections, grandfathers and grandmothers. Yes, CSRF is still possible. XXE, yeah, brother. So, of course, here's a lot of interesting stuff, right? But XSS, yes, thank you, Captain. So we start from the XSS. That's why, because it's still popular. Because The attacks that you mentioned, guys, in the chat, most of these attacks, their main target is a server-side attack. And if your organization that have the web servers or web application, of course, you invest some money in the protection technologies like web application firewall. That's why for researcher and for beginner researcher, it's quite too difficult to find server-side vulnerabilities, because even if you will find some strange behavior that probably leads to SQL injection, for you it will be difficult to exploit this SQL injection, because the web application firewalls didn't allow you to organize the exfiltration from your target. They are blocked. So that's why attacks against the client, against the browser, they're still popular, and you can attack the client. That's why you can show the impact in the bug bounty programs. That's why cross-site scripting is the first part of our presentation. So basically, if you open the Wikipedia, you will find something like this description from this slide. But cross-site scripting basically is injection of JavaScript code or injection of arbitrary content in HTML and in the browser. That's the idea is quite simple. You can inject something to the user browser. There's a dummy description, but I think it's correct. So there are a type of different examples how you can organize what is a cross-site scripting from the researcher point of view, how to exploit this vulnerability. So first, if you have ability to inject JavaScript or HTML code or any kind of content with HTML content, in case of if you're able to inject JavaScript, you can organize the interesting vectors against the browser of victim. And question for you, colleagues. If you are able to inject JavaScript, what you can do with the browser? Of course, you can show the alert script, or you can show some pics. Hi, David. So you can show something sensitive, but what kind of interesting vectors? Hijack cookies, that's also for grandfathers. Steal cookies. Redirect, yes, redirect is interesting. But steal cookies is most trivial. Currently, not all browser allows you to steal cookies. Keylogger, yes, exactly. This is one of the interesting vectors. When you can bypass, you can steal something. You can inject iframes and you can steal credentials. Or what is the most popular scenario of 2 years ago? I think it's inject JavaScript for mining, but it's still actual. You can mine the Bitcoins or any kind of coins. So right, but this example on the screen demonstrates that you can share link with your target, and your target open the link, and then something happens. What could happen? So this is an example what you can organize. First of all, clickjacking, session hijacking, etc., that you mentioned. You can spoof the content, the good platform for phishing. You can steal the credentials. Not so interesting, but depends on the vector and depends on your goals. You can organize the crypto mining on if you have additional protection systems or additional protection methods. For example, anti-CSRF, doesn't matter what is a CSRF, but CSRF is another attack. So cross-site scripting allows you to bypass some kind of protection technologies and protection techniques. And HTML5 brings new opportunity to show your camera, to show your sound using the HTML5 special tags. And also, if you have an opportunity to insert these tags, insert the malicious JavaScript, you can use this keylogger, you can use this HTML5 to steal some private data. So what is example that we have found different? I found different XSS and different kind of routers, medical systems. That's why my personal experience also related to cross-site scripting too. So you can find it everywhere. You can find it in medical system, in any routers that was in my flat, any routers was with cross-site scripting abilities. And also the latest model. And also we have interesting story when 2 years ago in Kaspersky, I've tried to research the link router for the vulnerabilities. I found some critical vulnerabilities and started from XSS. Of course, it's not critical, but I found some vulnerabilities in the link router. I send them router and send them report that, guys, please could you patch your vulns? And those guys said me that, yes, we will patch it, but also could you please help us to assess our top router, the router of our high-end class that has some software development lifecycle that's secured. Probably you will not find something. And first bug that I found in this high-end router was XSS, was the cross-site scripting. So this was example from my personal experience. Now, fundamentals. So we need to learn these vulnerabilities. We already know that it's an opportunity for us to achieve, to get some bounties. Yes, that's why we need to learn the different types of vulnerabilities. And there are basically two types. It's reflected and stored. And some researchers highlight the additional type of vulnerability, like DOM-based XSS, but DOM-based can be still reflected and stored. That's why DOM-based XSS is out of scope of our presentation, but it's like a third class that you need to know about it. But you need to understand only two vectors, only two types of vulnerability, is reflected and stored. Self-XSS is not a vulnerability. Yes, somebody trolls me that self-XSS. Self-XSS, it's only XSS for your mom, because you can demonstrate the impact somewhere. You just demonstrate the impact in your browser. Yes. So the stored XSS, the basic principle is just you can submit JavaScript code in somewhere in the server, and the server will reflect this JavaScript code to any kind of visitors who visit this page. So I think it's pretty interesting because your payload, your code, your script code, if you're submitted once in the server, it's stored on the server, and then it reflects for each user who visits the page. And you can collect a lot of sensitive credentials probably. So the impact from this attack is the higher impact that you can extract from any type of XSS. The second one, reflected XSS, is the XSS that not stored on the server, but reflects from the response, with the response of your server. If you send request with the payload, server immediately send you response with this payload that executes in your browser. And this is difficult to exploit because you need to share this link, or you need to share somehow this link that will send the request from the user's browser. And you need to initiate this request somehow, that you need to ask your user, could you please click on the link? That's why this reflected XSS is difficult to exploit, but still in some bounties programs, you can extract some money, you can get some money from the reflected XSS. And next step for us is just understand where we can find right now, just set up our environment right now, where we can find it. And according to public research, you can find XSS not only in proprietary software or in the web applications that was right for especially for banks, organizations, but you also can find it in open source software like Flower. This is an example that I found recently in open source software that related to microservice development. Flower is a dashboard. It's a dashboard that, if you're a developer in the Python, you can extract, you can use this dashboard to organize different threads for your applications, multi-thread. And this dashboard allows you to manage each process of your microservice, manipulate by data in this microservice, etc., etc. It's something like the RabbitMQ for the Python developer. And Flower, it's a dashboard for this system, but this system has only one field. If some example, for example, Igor Kuznetsov from our chat, if he will try to extract flowers, if he will see the active field, only one field, he will inject there, obviously, the string that he's injected before in our chat. Script alert script is a simple JavaScript that shows you the messages. message that with alert. And I'm like an eager Kuznetsov. I already did it, and I found that this dashboard was interesting. It was vulnerable to cross-site scripting. But for a researcher, it's not just interesting vulnerability, right? Because it's difficult to exploit. But in this case, it was stored XSS, so it's not difficult to exploit. But it means that if you found some vulnerabilities in open source project, probably you can find more interesting vulnerabilities. In case of my routers and that I mentioned before in the link, I found XSS. I started dig deeper, and I found hard-coded credential, command injections. And I'm sure if you will find some XSS on the project, you are able to get more interesting bug. It's a red flag for you that you can extract more interesting scenarios. So if you're faced with the XSS, don't stop. Another vulnerability, IDOR. Do you know what is the term IDOR? Insecure direct object reference, right. Why I mentioned this vulnerability? Because, of course, it's a server side. And as I mentioned before, we need, if we are beginners, we need to collect a lot of crown of jewels. And we need to collect as much bounties as possible from the start point just to keep our motivation. That's why I think IDOR is the most interesting bug, server-side vulnerability, that's still present on different kind of systems. And you can find it without any deep understanding how your application works and what kind of backends you need to research. For example, in case of SQL injection, you need to research the type of database, the structure of the tables. You need to understand what happens on the backend. But in case of IDORs, you immediately see your results. That's why it's interesting and easy to understand what is that. So basically, insecure direct object reference, or IDOR, it's a vulnerability that related to misconfiguration of access control list that allows you to change some parameters that's not for your privileges. And you can get unauthorized access to this pages, to these resources, etc. And basic example of IDOR is the arbitrary shop that, for example, has some IDs for shop cart. And if you collect your shop cart, you can pay. You can tap the pay button, and that's it. But in case if your e-commerce application has the IDOR vulnerability, you can change the number of your shopping cart, and probably you can see not your shopping cart as a simple example. Or if you are not administrator, but if you're just owner or guest, or if you're a user of arbitrary resource that has the administrative privileges for something, I don't know, for private page, for private threads in the forums. And if you find the IDOR vulnerability, you can just change the IDs and check, is this hide content available for you or not? That's why I think it's not the vulnerability itself, it's just misconfiguration of access control lists. And let's go back to the tools, and let's understand what we need to do to find these vulnerabilities, what kind of tools we need to find, and from what we can start to search for cross-site scripting and for IDORs. And we can use BurpSuit, of course, if you know how to use it. You just need to collect all links. You need to change the parameters in the links. But we can use the most interesting, I think, more interesting tools without the BurpSuit license. I'm not able to show you my screen, but I think I can tap some comments. For example, we have list of domains that we collected before from the sascon.com. And if you input this domain list in the tool that I will show you, you can extract all parameters and all links that was collected by search engines regarding these subdomains. But we missed the second step. We have 3 steps. We collected domains. Then we need to check, are these domains related to applications or not? Maybe it's just registered domain. And third step, we need to extract parameters for each subdomain name. So this is a basic workflow of our research. So we already used MS to collect as much as possible subdomains names related to our target. Next step is to check if we will have some big list of subdomains. We need to use tools that check common ports for availability of web applications. And one of these tools was developed by experienced bug hunter Tom Nam. Tom prepared the Docker container with his tools that allows you to use the pipelines between each step that you perform during your application security research. So this is example of the command that we input all subdomains, all domain names, and then we launch the tool that starts probe any kind of port, popular ports, popular for web applications like 8080, 443, or 80. So the different popular ports for web application. And if you have the huge scope, if you have huge attack surface, you need to extract as much more relevant application for your research. So this is the immediate and the second stage of your research. You need to collect applications because not all domains contains applications. Then the third step for you is to understand where the parameters, because you need to check, you need to assess the parameters for each domain name. That's why you need to use another tool from this Docker. It's a tool that we call Wayback URLs. Wayback Machine is the web service that allows you to extract links that was collected by different kind of crawlers or bots that periodically scan internet and scan the website for response. So the logic of the bot is quite simple. He open the URL. If URL contains web applications, he crawl the application. He to collect all links, all parameters that contains in the response of this web application. And Wayback Machine is the web service that collects the database that could be useful for you if you want to extract the URLs. You can extract the URLs in the format of URL and / parameters. This output of this tool will be useful for you if you want to assess your parameters for cross-site scripting. So if you want to inject script alert script, you don't need to inject it in the chat. You just need to collect the special request that responsible for sending the message in the chat and insert script alert script here. That's why it will be, you have a better chance to discover cross-site scripting. And then if you see here in the parameters, after you scan your domain names for different kind of parameters, you can see there numbers, you can see there text or any kind of integers, the parameters with different types. And based on what you digging, what you're researching, you can input there different kinds of payloads. And for cross-site scripting, of course, it's script alert script, image, etc. There are a lot of different payloads. For that, you need to use the fuzzing techniques. And fuzzing, I think it's out of scope because it's interesting tricks that allows you to brood different parameters and to assess the results, the response of your target based on different kind of your input. So, but for fuzzing, I mentioned the tool FUF or BurpSuit. You can use the BurpSuit or WASP-ZAP for that. But FUF is fundamentally more interesting because you can insert the FUF in your script, or you can insert the FUF for your bash command line. So the FUF, it's kind of user-friendly if you love the console input. And also FAV, it's a Go written tool based on Go. It means that it's more fastly than BurpSuit with Java engine. And you can organize, you can write your BurpSuit with blackjack based on FAV. So that's why I totally recommend you to use these three steps. First of all, let me summarize. First of all, look what kind of vulnerability you want to research. Understand if aspects of this vulnerability. Choose the most interesting vulnerabilities with higher probability to find. Then collect the attack surface. Collect the all interesting assets that exposure to the internet. Second stage, check all assets for web applications, because if you have domain list from the 1,000 domains, it means that probably not 1,000 applications available there. So you need to check it. Use HTTP Pro for that. And the third stage, for each domain you found, for each web application you found, try to use Wayback Machine to extract all parameters. And only after you have some database with attack surface and parameters, try to assess. You can do it manually, but you can use the automation like fuzz or automation scripts for the BurpSuits to brute your parameter. So I think, guys, we almost out of the time. That's why I think we need to conclude something, and also we have set the roadmap. But the final stage of your research should be not just a vulnerability, not be bounty, because bounty is a trivial, right? We are doing it not for the bounty. We do it to save the world. We do it to secure our assets. We do it for Hall of Fames, maybe. Someone do it for the Hall of Fames. That's why the reporting is an important part of any kind of vulnerability research. Properly written report can save you a lot of time. And during the multiple penetration tests, multiple bug bounties, private bug bounties, I think only two stages of research is important. First stage is reconnaissance, and the last stage is reporting. If you missed something here, your research could be canceled or rejected. If you missed something on the reconnaissance stage, of course, your research will be not so effective. That's why I think the reporting how to fix your vulnerabilities is quite interesting, and it's quite useful. And the final conclusion, we do it, you know, that any kind of bug hunting, it's not about the talent. It's about mostly who is the hungrier, right? You don't need to be the top talented researcher. You just need to keep your motivation, and you need to keep your calm and dig deeper. Because sometimes not all of us have enough passion to dig deeper. Maybe you have more passion than another researcher. So the main conclusion is that we are here. We are not hunting for vulnerabilities. Yes, we're hunting for knowledge, and that's why we're here. That's why we're here, right? Thank you, colleagues, for your time and for your attention.